Welcome to today's session, and I'm Carl Olson, the producer of this session, and it's my pleasure to introduce the topic and speaker. Before I get to that, just a couple of housekeeping items. We ask that you silence all devices that you have on you, so that we don't have any distractions from annoying little beeps and clicks. And also, because it's a short session, we're going to have 5 minutes for questions at the end. Please hold your questions until that time. With that, I'd like to introduce our speaker, Ariel Rodriguez, who is from Scuba. He's their Vice President of Data Science and Research and Development, where he leads product experimentation and machine learning initiatives to expand Scuba's product reach and capabilities. And he's going to be speaking to you on the topic of activating machine learning-driven insights from real-time customer event data. So, Mr. Rodriguez, the floor is yours.
Thank you. Well, thanks all for joining the session today. I hope you take something meaningful and valuable for you. I'm going to talk about how to activate ML-driven insights from real-time customer event data. But before that, I'll give you a brief intro about Scuba. Scuba is a trusted real-time continuous intelligence platform. Its origins are actually in Facebook, where a team in Facebook was trying to scale data discovery, and the technology was spun out of there. Today, we serve many of the largest technology companies as well as media companies. And using our product, they analyze 150 billion events per day, 500 million active users within their implementations, and they get annual savings of over 500 million as a return on investment. Scuba, as the diagram shows there, can scoop data from any source to power some of your most valuable use cases, such as personalization, omnichannel measurement, behavioral analytics, acquisition pipelines, or predictive intelligence. I'll go into the predictive side of things today in depth. And this is pretty much what the platform consists of. So it's a continuous intelligence platform, meaning it's a full stack, unified experience for you to do analytics end-to-end, from connecting to real-time event data sources to doing the exploration and the discovery of insights of value, to activating those insights and making them part of some decision process, executing in platforms. And the way it works is via simple configuration files, YAML files. You define those pipelines to grab data from real-time event sources or historical databases or data lakes that then has the data populated in the platform, where business users or product analysts or product owners can then take advantage of a low-code interface or no-code UI to find useful insights. Data analysts, data scientists, more advanced usage can be done with an API programmatically, where you can then bring in machine learning tools. We support the leading frameworks today, as well as using those same APIs to activate those insights, whether they are ML-based or non-ML-based. They can be activated in channels, execution channels, such as marketing platforms, CRMs, etc. We do that all within, when we ingest data, is schemaless, so there's flexibility in how data can come in, but at the same time providing you tools to govern that data by self-generating data dictionaries and tracing all the data transformations that occur within the platform. Within Scuba, all transformations, including things as complex as machine learning models, are metadata. And that's a very powerful approach to doing continuous intelligence. I'll go into that further. So I want to go back to the concept of continuous intelligence, which was introduced maybe like 4 years ago by Gartner, looking at trends that would dominate, the space in the next 5 years. We're still within that time frame. They define continuous intelligence as a design pattern in which real-time analytics are integrated into business operations and processing current and historical data to prescribe actions in response to business moments and other events. So I want to highlight that it's real-time, has to be integrated with business process or operations, and that it has to be responsive in the moment to business actions, customers' actions, et cetera. So why revisit this concept? In my 20 years doing data analytics, data science, I think this has always been the goal. Like, it's always been a mission of analytical teams and product teams to activate insights, and ideally in real time. Making data actionable, making discovery actionable has always been our goal. Today we have the technologies to do that. We have a lot of learnings about, from how we've done things in the past. So I feel like this is much more achievable today than any time. And actually, I'm going to illustrate how you can experience a continuous intelligence the paradigm within the Scuba platform as an illustration that it's here. It is possible. So first, we have a take on what continuous intelligence is, and it's basically has these three pillars: universal connectivity, data fusion and discovery, and activation and measurement. And these become really the pillars also of activating machine learning or AI into your analytic cycle. And in addition to that, it has to be on a unified cycle, meaning everything has to be within the same analysis experience. No jumping around from platform to platform, no need to orchestrate data pipelines from one stage to the other, but all occurring within the same process. So universal connectivity is feeding data from any source, doing so fast, meaning taking data from real-time sources, being adaptive, not having to impose structure on the data. This is where schemaless capabilities are important. But then the ability to add semantics to the data, adding taxonomies, for example, that's an important aspect of it. Data fusion and discovery is once data from all sources come in the form of events, then being able to link those streams of events by actor, by time, by the sequencing that happens naturally in the data to find insights in a scalable way. Being able to query that data fast and comprehensively is an important requirement in continuous intelligence. And finally, activation and measurement. So you can't stop at just the discovery of an insight, but you have to make it actionable. And actionable also means deliverable, meaning that it's auditable, that it's reproducible, and that is fairly automated to a point that it can be delivered consistently into a platform for execution. Marketing is, again, a typical use case of that. And finally, measurement. Being able to have all the data elements to also keep track of performance of the decisions that you're making with your data and with those insights have to happen within the same experience. Before getting into the benefits of continuous intelligence for ML, let's walk back and see what is being done today predominantly, and how we have evolved that model to the modern stack, the modern data stack, and how then continuous intelligence would compare to that stack based on the challenges that we're actually having with the modern stack. The workhorse has been the ETL process. I'm calling it here the legacy ETL process. Extract from multiple data sources. Those data sources may be supporting a disparate set of applications, each one with a different kind of data storage. Extract that data on a recurrent basis, transform it, meaning pass it through a series of phases to get to more semantics in the data. First, a raw stage, just as it came in from the source, then a conform stage where you have cleaned up and provided some structure, and then a semantic stage, which is when it's ready for consumption. In the ETL model, you load that into a data warehouse, and it's ready for consumption for your information consumers, business intelligence, analytics, and ML as well. What is typically supported in that model is more batch ML or analytical ML, meaning you can build models, much more difficult to integrate them into operations because all the transformation happened beforehand and the sources are coming in the raw, whereas all the ML is operating on transformed downstream data. To that then came a challenge, which was then flipping the L and the T. Very simple, right? And that came obviously with the advent of the cloud, the rise of the cloud data warehouses. Amazon Redshift, BigQuery play a key role there. Nowadays, of course, Snowflake, Databricks, and others are leading the way in that space, not only as data warehouses, but also as data lakes. But in the modern then ELT, compute is cheap, storage is cheap, you can collect data very fast, data is also coming faster, and you can drop it all into that platform, and you push some of that responsibility of transforming the data for insights to your consumers. You're providing them the capability through that, through the warehouse technology, but also they have better tools today. The advent of Tableau, Power BI really benefited from this kind of like ecosystem developing, right? And analytical ML was possible, operational ML was also possible. Now with that, better computational resources, but predominantly in batch as well. So you could bring back output of models into operations, but mostly in batch. This model stack has evolved and now is very complex, very powerful as well. Now we have integration and also orchestration layers. We have observability so that you can see globally how these steps within the process are sharing data and executing on the data in each of them. But in essence, they remain about a similar structure or architecture. You're extracting now through integrations mostly with APIs. You're loading into data warehouses or the data lakes or the lake houses or the mesh. Obviously much more powerful tools today. And then activation is happening through reverse ETL technologies. And this is where you can connect to the BI and the analytics tools. You can connect to operations. You can feed experiences with those insights. And then machine learning has taken a life of its own. A box, actually protagonist within the stack, but having a lot of challenges to find the way where to play, where to properly integrate with this stack. You can have machine learning platforms taking data from raw source, building powerful models, but then having to be brought back into a data warehouse where they lose speed, they lose then the power of the moment. There's also in this architecture a lot of handoffs, a lot of data handoffs, a lot of contracts that need to be respected and put in place. There's also still a need to predefine the structure in the data so that the tools downstream can predict or can, I should say, can anticipate what the data is going to look like. And that brings up other issues about timing. You have then the activation working within out of sync windows, or you have ML islands, meaning you have powerful tools at your disposal, you have great data, you can build very powerful models to predict things that will be valuable in operations, but bringing them back into production or integrating them effectively becomes a challenge. The business is also affected in that it's no longer about the business goal, but more about tech requirements, or the business goals is in need to translate into tech requirements to make it feasible or get it accomplished. So really my thesis today here is this one. We believe that the customer intelligence solutions that are being built in these legacy or even the modern stacks fall short of that continuous intelligence paradigm, that ideal of analytics where you have a very short time to discovery, short time to insight, and a short time as well for activation or action. And today, the digital experiences that they're supporting are requiring faster response as well. So they're falling short on that. And the users themselves, the users of these tools, who have to provide for the product owners and the business in a faster way, are also not satisfied with this approach of organizing the data processing. And more importantly, which is really the main point here as well, is that ML adoption is affected. It is burdened by all this orchestration and this sequencing of pipelines in a way that is making collaboration even difficult as well. This is not only my opinion. I mean, it's plenty of research out there, market research. Here I'm highlighting Forrester's recent study on challenges that organizations are facing when trying to operationalize machine learning and AI solutions. 57% of responders believe silos between data scientists and practitioners inhibit deployments. 73% of responders find transparency, traceability, and explainability of data flows challenging. 47% of respondents say their organization struggles to drive actionable insights from their current ML strategy. And 48% of responders find that their organization is having difficulties seeing a difference in business, meaning value, after adopting AI ML solutions. This is big. I mean, it is significant. We have great tools at our disposal, great architectures. A lot of advances have been made technically, but yet we still face challenges in working together, making actionable the things that we discover, and pretty much finding value or measuring value of it. Adoption is burden. How? Well, typically you have different teams working on different stages of the process, and each team with a preferred solution, a preferred technical solution. So data collection, data preparation, typically done by data engineers. They use certain tools there. A lot of contracts need to be defined there. ML developers or data scientists, they don't have full visibility of the progression of data, how it has come from upstream data to downstream data, and they cannot use it all. Actually, they have to pick a stage within that process to take data out, train their models, and then deploy those models back in. DevOps, again, is disconnected from business impact tracking, and product owners feel like they don't own the process. They are trying to keep it all together, but it becomes a technical management experience rather than a business management experience, getting to the goals. And you know, this is where continuous intelligence can provide a solution to that, where you are collapsing a lot of these stages of the process within a unified experience. So the activation happens within, the data connection happens within, the discovery, including machine learning, happens within, and that in turn then benefits activities like machine learning. I'm gonna skip this slide here, but or briefly touch on it. Within a unified experience, then everybody's working within the same tool. Everybody's seeing the data in a similar way, and the collaboration then leads to faster ML deployments. I have a demonstration. I want to see maybe a couple minutes, maybe 3 minutes, to go through the demonstration, because product architecture discussions are great, but I also want to show what you can do with it, which to me is much more important. let's take a demo example, but very typical of marketing use cases where you have an experience. Someone can go into a homepage, do a search, look at search results, and in the end, we want to know if we should reach out to that customer and when do we reach out so that we can influence the purchasing decision. And I want to know at any point in time during that journey how likely that customer is to finally make a purchase. Can I do that with continuous intelligence? And yes, I can. First I have to connect the data. Through configuration, I can connect to data sources like Kafka, event streaming. No need for complex data pipelines, self-service connection to real-time data. As data comes in, we have self-documenting data dictionaries where access can also be controlled and data can be governed. Very easily, in a matter of minutes, I can build up dashboards showing my KPIs or my OKRs and can put together the business case. This is the journey I want to analyze. I want to know who's likely to purchase. No human can really make sense of out of this diagram or this chart to optimize who to contact and how to make that more effective, that journey. So I'm going to use ML. And within the same experience, I can use low-code tools. I can use Python, R notebooks. I can bring my own advanced machine learning tools through open source MLOps tools and activate those models within the platform. I can then monitor the performance of those tools, recall, precision, volume of predictions, confusion matrices to understand if that model would be effective when I put it into action. I can then activate those insights. I can use them all to identify a segment of users or customers who I want to contact through an execution channel. Within the same experience, I can activate that population identified as likely to purchase and send it to my channel of choice. And finally, put together a measurement plan. Once I've taken action with that audience in a channel of choice, I can look at an A/B test, put it as part of my tracking dashboard, and look at the business impact. This is an example of how continuous intelligence would work, all the way from connecting data, making discovery, and activating that insight into execution platforms, measuring impact back into the same experience as I believe it's a powerful paradigm to continue to pursue. Recap, CI paradigm is very strong, very fit for AI/ML, more relevant now given the challenges we're facing with the legacy and modern stack. AI/ML in continuous intelligence is here. Just show you that it can be done. And it effectively addresses the current challenges, breaks down silos, keeps traceability of data, visibility, streamlines adoption of no-code, low-code AI, and integrates seamlessly also with activation, and finally closes the loop on measurement and business impact. So with that, I'll open it up to questions.
Okay, thanks very much. That was a great presentation, and I think we all appreciate it. Before we take questions in the room, there's a number of questions online, many of which, as I look at them, are probably going to take too long to answer. But you might want to answer them after the fact, by email or something like that. But one person asks about data quality. They said, suppose that the data coming in is of such poor quality that your machine learning system can't really process it, or do you have a safeguard against that?
Yeah, no, fair question, and I think that that also highlights some of the benefits of a unified analytics process, where as soon as data is connected, you can discover such quality issues, and you wouldn't go forward with machine learning if the data quality would not support other types of analytics, other types of intelligence. So I think it can be addressed before tackling the machine learning exercise.
Okay. Are there questions in the room? Anyone? Here's one. And I remind you that You need to wait until you get the microphone because the people online won't hear you otherwise.
Thank you. How do you train your models to be able to interpret the data when it's schemaless? And how do you make sense of the data?
Yes. So it's schemaless ingestion. So there is schema discovery at the ingestion time. Basically, the ingestion process will then expand on, say, for example, nested structures or varieties of structures for an event type. Then it gets stabilized. Then it can be used for machine learning. So schemaless is for the ingestion process. Then it gets stabilized by discovery, by auto discovery of that model. Yeah.
Other questions in the room? I guess we can go to one of these. How are your real-time customers utilizing machine learning to their advantage? It's a broad question.
One of the key use cases is activation. Again, making ML-driven insights actionable in the channel of choice. We have many customers who have marketing use cases. They identify a population that they want to take action on in the CRM of choice or in a communication channel of choice. And machine learning then provides them a predictive capability to accomplish that, in addition to the ad hoc discovery that they can do with the tool.
Okay, great. Yes, over here.
Thank you. I'm not sure if I got it right, but you're proposing not to have a master data layer and instead just process the data, extract, load the data, take no care at the format of the data, and use it without having a structured master data layer?
Where a solution like ours excels is taking data directly from source, but it assumes that you're doing that regardless. You are still sending your data to a data lake, that you are still cataloging that data for other production purposes, right? But that Scuba then makes it it's much more flexible for domain owners, business domain owners, data domain owners to accomplish their goals with the same data. It's not necessarily wanting to assume all that the governance functions would provide.
No, so it is not an alternative to best data management practices, but it's specific for real-time use cases, connecting real-time data that's coming to our enterprise, and then processing it in real time and connecting it in to some activation platforms.
That's right. That's right. So think about it as a tool that would, in the hands of domain and business owners, can help them be more agile with their insights and turn them into actionable ones right away with much lightweight infrastructure that can still play with that existing infrastructure, can still be connected to the data lake if you desire that to be the source of data, or can play with directly with the data sources, the streaming data sources, if you choose so.
Okay.
Yeah.
Well, I'm afraid that's all we have time for. I want to, on behalf of CDOIQ, thank Mr. Rodriguez for his time and his valuable insights and this wonderful presentation. I want to thank you all for participating as well, both in the room and online. And that's the end of our session. Thank you.
Thank you very much.